Lesson P.5 is solving equations graphically, numerically, and algebraically. So this is using a whole bunch of different techniques to solve. Now, we're not just talking the basic linear, okay, some of the linear equations where you're just moving x's to the left, numbers to the right. We did that back in, I think it was P.3 or P.4, okay? This is solving, we're focusing on our quadratic techniques, okay? You saw a couple of them on that pink formula sheet, okay? We're going to talk about quadratic formula. We're going to talk about completing the square, okay? Those, types of methods. So, our first step, though, is factoring. Probably the easiest one to use, probably the one that we are the most proficient at, I would say. It just doesn't always work. So, when we talk about factoring, officially we're talking about the zero factor property, which says let A and B be real numbers. If A, B equals 0, then either A equals 0 or B equals 0. Okay? Basically put, if two things are being multiplied and they equal 0, then that means one of them is 0. Okay? One of them has to be 0. So, solving this equation by factoring. 2x squared minus 3x minus 2 equals 0. What do we remember?
They have to multiply to be the middle number, but add to be the third number. There's a flip-flop.
Flip-flopped.
Okay.
But then there's also another catch with this one.
Oh, the 2. You have to divide the 2 out first. Oh, no.
Except I can't divide the 2 out nicely. If we could divide the 2 out nicely, okay, so what Katie's pointing out is we have that, when we go to factor this, there's an issue because there's an a value, right? It's 2x squared instead of just x squared. If we could divide the 2 out nicely, I'd be all for that. But unfortunately, it's not going to divide out of the middle term very nicely. Product and sum, it's product of AC. So when Katie was talking about product, multiplying and adding, you just had it reversed. But then we have to include the AC here. Now, in order to do that, realize your equation does have to start off by equaling to 0. Okay, so when you go to do something like this, make sure when you start, just kind of a side note here, the equation must equal 0. And let's see, if we talk product of AC, okay, AC is what? The 2 and the negative 2. So 2 times negative 2 is negative 4. So we need two numbers that give us a product of negative 4 and a sum of
3.
Your B value, which is specifically negative 3. Okay? So I need two numbers that multiply to be negative 4 and add to be negative 3. Well, multiplying to be 4, what are my options? Multiplying to be 4 is going to be 1 and 4 or 2 and 2. How do I get the 3? Yeah, we're going to have to somehow use the 1 and 4. I heard negative 4 and positive 1, right? What do we do with these two values when we're doing product of AC?
X. Something like that.
No, we're not done yet.
2x squared plus 1 or minus 4, and then one of those minus 6.
Yeah. So we're taking these two values we just came up with, and we're splitting that middle term, okay? That minus 3x is either going to be plus 1x minus 4x or minus 4x plus 1x. Just go with what looks best to you. It doesn't matter. It all works out in the end. You guys have a preference for me?
Plus 1.
Okay, that's what I was trying to write, so that's what we'll get. So I split that middle term into plus 1x minus 4x. The first term, 2x squared carries down, and the last term, minus 2 carries down, and of course the equation still equals 0. We've got 4 terms. Is this coming back to us then? 4 terms, so we're going to split it in half. What's the GCF of the first half of 2x squared plus 1x? They both have an x. No number though this time, right? So if you factor out x, 2x squared divided by x is going to be 2x plus 1x divided by x is 1. Minus 4x minus 2. What can we factor out there?
2. Negative.
2, but we need to make it a negative 2 because this first number is negative. Okay, when that first value is negative, factor out negative. So negative 2, negative 4x divided by negative 2 is positive 2x. Negative 2 divided by negative 2 is plus 1. Still equals 0. Notice what's supposed to happen here. The parentheses are supposed to match. What's my factoring look like then? 2x plus 1, which is my matching factors. X minus 2, which were my GCFs. Am I done?
No.
Done with factoring, but not done with solving the problem. Because it was an equation, it was equal to 0, we were told to solve. So now what? Yeah, set each factor equal to 0. 2x plus 1 equals 0. X minus 2 equals 0. So I'm going to subtract 1. 2x equals negative 1, and then x equals negative 1/2 when I divide by 2. Over here we have x minus 2. So we have x is 2. So we have 2 answers that work here. X equals negative 1/2 and x equals positive 2. Does that sound familiar?
Yeah.
Okay.
I thought it couldn't be a negative.
No, these can.
Well, you're supposed to pick one that is and pick one that isn't.
No.
I remember doing it. We factored out or something, and then we picked one that worked and one that didn't.
That's why you have to plug it into the equation. And then you have the one that works and the one that doesn't.
If we have extraneous solutions, maybe? Is that what you're
Oh.
thinking?
Sure. I don't remember what it's called.
I don't know. That's I'm trying to figure out what you're talking about. So maybe, sometimes you can always check your answers, but there's no reason that these wouldn't work. Sometimes when we have things like square roots and stuff, we get extraneous answers that don't work. So maybe that's what you're thinking about. But that won't be an issue today, I don't think. Okay. Solving by extracting roots. Fancy wording, but you've done it. You know what to do here once you realize it. So quadratic equation is the one that can be written in the form ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a cannot equal to 0. That really should have been up there. My apologies. Because that was the form we had up here, right? This is our vertex form in a way. But solving by extracting roots, I don't know, do you guys remember what this means? My hint is that 2x minus 1 quantity squared is a perfect square. Yeah, take the square root of both sides. 9 happens to be a perfect square, it wouldn't have to be. But when you have a set of parentheses square here, one option is that we can solve using square roots. So when they say solve by extracting roots, that's fancy terminology for solve using square roots. Okay, so that means I'm going to take the square root on the left. That also means if I take the square root on the left, we take the square root on the right. What is the square root of 2x minus 1 quantity squared? 2x minus 1. What is the square root of 9?
3.
Sorry, I'm writing a side note over here. The fact that what we did, we square rooted both sides. Is that it?
No. To solve for x.
I'm not quite ready to solve for x yet. That's part of my solving for x. I need a little bit more than just Katie's 3.
Would you subtract the 3 to the other side?
No. Go back here. 2x minus 1 equals 3.
You'd subtract that.
Positive and
Or negative 3.
That's
Oh, yeah. Okay, so the hint or the reminder, when you are taking the square root in an equation setting, you heard me say this last year, right? When you take a square root in an equation setting, you have to account for the positive and the negative root. So that's why we say 2x minus 1 equals plus or minus 3. And now I'm ready to solve. Except technically, what are we doing here? We're technically solving 2 equations. Okay, so officially we're solving 2x minus 1 equals 3, or 2x minus 1 equals negative 3. Okay, do your math. So in this one I have 2x equals 4, so x equals 2. On this one, two and negative 1 is your answers? I'm assuming we can handle that very basic solving. Minus the careless mistakes you just made with negatives or whatever you might have done along the way, right? Okay, so that is solving by extracting square roots, or by extracting roots. It's basically the taking the square roots of both sides. You almost always see that method introduced at the same time that we introduced completing the square. Okay, I introduced them at the same time last year in Algebra 2. We talked about extracting the roots, and we talked about completing the square, because when completing the square, there's several steps, and it's kind of, this is where we pick up like halfway through. Okay, so shall we solve by completing the square now? Okay, to solve by completing the square, first of all, you're going to want your equation in this form here. X squared plus bx equals c. That's always going to be step 1, so to speak. Okay? Step 2 is going to be that you're going to add b over 2 squared to both sides of the equation. Okay? So we're going to solve. We're going to get x squared plus bx equals c. We're going to find b over 2 squared, add it to both sides, and then we're going to factor the left side of the new equation. Okay? And the fourth step that I usually give this is 4 steps, and my fourth step is to solve using square roots. Okay? So, and this is just kind of the fancy showing you in terms of B and C. I'm more worried about let's show you in person. So step 1. Step 1 is I want this to be x squared plus bx equals c. Is it in the form x squared plus bx equals c?
No.
Nope. So what would you like to do? Okay. Let's minus the 17 over. And that's going to give me 4x squared minus 20x equals negative 17. Have I completed step 1? It's not just about getting the x squared and x terms on the left. This specifically has to be 1x squared plus bx. Notice there's no a value there. So you have to get that x squared by itself. Okay? With that in mind, that's going to mean dividing by 4 here, yes? So in terms of dividing by 4, that means we divide everybody by 4. The good news is the dividing by 4 is nice on the left, correct? So as long as it's nice on the left, this will work. So I now have x squared minus 5x. Notice I was kind of leaving a gap there, wasn't I? Equals, I'm going to leave it as negative 17/4. Okay? You could put a decimal there, but I don't have to grab a calculator at this point to think it through. Now is step 1 done? Yeah, now we have 1x squared plus bx equal to a c value. Okay, step 2. Add b over 2 squared to both sides. So we're going to have to talk about what that means. So we're adding b over 2 quantity squared to both sides. And I'm putting these here, but realize these notes are, remember seeing completing the square on that yellow paper? These notes, you have these steps, don't you? I don't know that I wrote them exactly the same, but probably pretty similar knowing me. Okay, with that in mind, in order to add b over 2 quantity squared to both sides, I need to know what is b. -5, yes? Notice she picked the current b, yes? Don't go back and use what we could call the original b. I don't want the 20. I want the current b when it's 1x squared plus bx. So now, I don't know how much you want me to step-by-step this. b over 2, what's b over 2 going to look like? -5 over 2. And then, if I do b over 2 squared, that's going to become 25/4, if you will. Right? -5 squared is 25, 2 squared is 4, so 25/4. So this value here is going to, what am I doing with this? Adding it to both sides. So I'm going to say plus 25/4 here and plus 25/4 here. Really kind of glad I did not take that to a decimal. Step 3, because we'll do cleanup here as part of step 3. Step 3 is to factor the left side. Okay? The whole point of completing the square is we have created a perfect square. We have created a perfect square that automatically will factor into a set of parentheses squared. Okay? It will automatically factor into a set of parentheses squared. And if you need to for a moment, think this way. You can, but I don't necessarily write this out. What goes in the front of the parentheses here? Well, what's the square root of x squared? X. Or if we were writing out the two parentheses, I'd ask, what does x squared break into? And you guys would say, x and x, right? Now, if we're just going into two parentheses, now we ask ourselves, what multiplies to be 25/4 and adds to be -5? Look, but I know it's a perfect square. So the shortcut is that number we just added. What's the square root of 25/4? Where'd 25/4 come from? It came from the 5/2. Specifically, it came from a -5/2, didn't it? And so I'm going to put 5/2 here, or that's what would be going in here, if you would, okay? I'm going to put 5/2 there. How do we know it's negative? Well, we're going to use negative because it came from negative here. This was -5/2. My middle term is negative. -5x is negative, so this sign is a negative, or both signs are negative there. I promise it works if you FOIL it back. The fractions make you hesitate, I'm sure, but it does work because this is x times x is x squared. Then you've got minus 5 halves and minus 5 halves. Well, 5 halves is 2 1/2. What's negative 2 1/2 and negative 2 1/2? Negative 5, right? And then you can multiply it there. On the right, while we're here, go ahead and clean up. What is negative 17/4 plus 25/4?
4 or 2. Probably be 8/4.
Okay. My brain was thinking you guys were saying 2/4. Okay. Yeah. So it's 8/4, and 8/4 is 2. Don't ask. My brain just wasn't there. It wasn't with you.
I don't know why I said negative 24. Okay.
I got nothing. Negative 17 plus 25 is 8. I had that part at least. 8/4 is 2. Okay. Official final step. How do we solve this? It's x minus 5 halves quantity squared. So we're going to square root both sides. So this is where I usually say solve using square roots. Okay. So now what I do to the left, I do to the right. What is the square root of x minus 5 halves quantity squared? X minus 5 halves. What is the square root of 2? And? Plus or minus the square root of 2. No, I don't usually want a decimal in that scenario. I'm usually still looking for just the square root of 2. But don't forget, we took the square root in equation study, so plus or minus. Final step.
Okay.
And we're going to do that by?
Adding the 5 and
Yeah. We're going to add 5 halves to both sides. And so then we end up with x equals. My personal opinion is to put the plus or minus in the middle of the two terms. So when I write this, I'm going to move this plus 5 halves out front, and I'm going to say 5 halves plus or minus the square root of 2. Okay. Now, could you get decimal answers if you needed to?
Yeah.
It required the use of a calculator, right? Technically, what I did just right here did not require the use of a calculator. But if we needed to, we could plug that into a calculator and get it done. Okay. That's completing the square. Does that ring a little bit of a bell?
Yeah.
We did that last year. I don't know how well you grasped it, but we did it. I can't remember if you did it in Algebra 1 or not. Maybe, maybe not. Okay. We're ready for the next page. Notice it says solve using the quadratic formula. Okay. So solutions of the quadratic equation form ax squared plus bx plus c equals 0. So keep in mind it is based on this form here, right? As long as a does not equal 0, are given by the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, that's something you should work on memorizing. Hopefully it should be pretty familiar with you. It'd be a good one to know, to have memorized. Okay, solve the equation 3x squared minus 6x equals 5. What do we have to do first? Yeah. Notice this standard form here is equal to 0. You can't use a quadratic formula until your quadratic equation is equal to 0. So we're going to subtract 5, 3x squared minus 6x minus 5 equals 0. From there, what are we ready to do? Okay, plug them in. Do you know your ABCs? I'm going to write them down. You probably don't necessarily need to, but A is 3 because it's in front of x squared. B is -6. It's a coefficient of x. And C is -5. It's the constant. Okay, let's solve. I'm going to start with x equals negative b. So -6 is positive 6, plus or minus the square root of b squared, which I'm going to write as -6 squared, minus 4 times a, which is 3, times c, which is -5, all over 2a, 2 times 3. Do the math. Have you done some cleanup? What's going on under that square root? What?
36. Well, 36
Oh, okay.
minus 60? No, plus 60.
Okay, yeah. -6 squared is 36. And then it's a minus, but it's -4 times 3 times -5. So right there, my brain says, oh, it's going to be a minus times a negative, so I'm going to be adding. My brain personally is going to do 4 times 5 first, because 4 times 5 is 20, and then 20 times 3 is the 60. Okay? All over 6. So if I clean that up to where Katie had me, 6 plus or minus the square root of 96 all over 6. Okay. We're not quite done.
Here's what your 6 is.
I can't cancel my 6's.
What? Because this is.
Yeah. This 6 does, there's 6 here, but if I'm going to cancel a 6 in the denominator, I have to be able to cancel it with every term in the numerator. Right now, I don't have anything out in front of that square root of 96, do I?
No.
So I can't cancel anything with that square root of 96 right now.
Divide by 6. The 96 by 6.
Dividing by 6 isn't going to help because that 6 is still going to be under the radical. And I can only cancel what's outside the radical here. Or, well, wait, what's the other piece of 6? Ah.
I divided the square root of -6 by 6. Got 16. And then the square root of 16 is 4.
Okay.
And then I got 10 and -2.
Okay.
But 6 plus 4 is 10. 6 minus 4 is -.
Okay, whoa.
6 minus.
You're going a little astray there.
Was I close?
You got parts of it.
All right.
But then I think you lost part of your square root in the process or something. Because we're still going to have square roots in our answer. Which is where you went astray. Okay, so square root of 96. He said divide by 6, which just didn't do anything for my brain. What do we want to look for underneath the square root?
Something that 96 could be that would be a perfect square.
A perfect square, right? Now, what's the other piece? When you do 96 divided by 6, it actually is 16, yes?
Yeah.
So you're looking, in my brain, I was looking for, okay, we want to divide 96 by the largest perfect square we can, which it's a 16 times 6, yes? So I'm just kind of putting that there for a visual. So now if I clean this up the first step, I still have 6 out front for right now. The square root of 96 is the square root of 6 times 16. The square root of 16 is 4, so I'm going to put that out front of the radical. And then the square root of 6, it stays the square root of 6, so it's still under the radical. And then it's still all over 6. Okay? Are we good at that point?
Yeah.
From here, Now, if I want to cancel anything out of that denominator of 6, it has to be able to cancel in both terms on top. Yeah, we can't divide by 6, but can we divide by 2?
Mhm.
Yeah, we're going to divide each term by 2. So 6 divided by 2 is 3. Plus or minus 4 square root of 6 divided by 2 is 2 square root of 6. Divided by, or all over, 6 divided by 2, which is 3. That is one form of your answer. Okay, I can't go any farther with that. Okay, I can't cancel the 3's because they don't cancel with this 2 here. I can't cancel square root of 6 with 3 because 6 is under the square root, the 3 is not. So if you're leaving an answer in terms of fractions and radicals, this is where you stop. Okay? I will say if you are dead set, I want to cancel those 3's, well, there is one way we can do it in that if we think of this as 2 separate fractions. What's 3 divided by 3? And that is a 1, right? Plus or minus. Now, yeah, you're going to have that 2/3 square root of 6 there. So you could write it as 2 square root of 6 over 3 or 2/3 times square root of 6. This is an answer you can give. I don't think it looks anything better than that answer, though. Okay, but if you are bound to determine you want to cancel those 3's, that's the correct way to do it. Okay, could you plug this into your calculator and get decimals?
Yeah.
Okay, the other option is you could get decimals if you had to. Got it? Okay, we're running good on time. Okay. One more. What's it say on this last one? Solve graphically. Okay. Do you know how to graph x cubed minus x minus 1 by hand? I doubt it. I would struggle to graph that one by hand. So what are we going to be doing? We're going to be using the calculators to graph this, yes? Okay. So notice, now, where are we going to be looking for an answer? Well, the solutions of an equation, when given a graph of the equation, are the locations where the graph crosses the x-axis. To do this, we'll use our graphing calculator and the trace feature. I'm actually going to teach something a little bit more specific than just tracing so we get a specific answer. Okay, but we are looking for our official, where does it cross the x-axis? Do you guys recall the vocabulary word 0? Okay, they're zeros when they cross the x-axis is what we call them. Okay, so grab your calculators and graph this equation. Okay, did you get it graphed?
Yeah.
Y equals x to the third. So remember, variable x is right there, next to my alpha button. To the third, you have your exponent button, yes, which is the arrow, just like you have on a scientific calculator. It's over underneath clear. Raised to the third. You do need to arrow out of the exponent if you haven't figured that out. Minus another x, minus 1. When you graph that, I don't know, do you have any clue what you last graphed? Was your window a normal window, or was it had you adjusted it and it was all crazy? Who knows? My recommendation, what I tend to do before I graph something, is I automatically go to my zoom window and hit 6 for Z standard. because that gets me with a basic graph and not something crazy. Your graph should look identical to mine if you're on a standard 10 by 10 screen. Okay, so we haven't forgotten how to do the basics there, right?
Yeah.
That's good. That sometimes is already forgotten, right? Okay, now we want to know where the graph crosses the x-axis. So, now, one option, could we hit trace and try and trace over to it? We can. We can arrow to the right, and if I had to guesstimate, it's somewhere around 1.36. Fair enough? Now, here's the deal. I want something a little more specific than 1.36. Okay? Your graphing calculator will find you that exact value. It will find you that exact value when y equals 0. So everyone has it graphed, yes? What we can do here is we can, so the second function of the trace button, above the word trace, you see calc. We want to go into the calc menu. So I'm going to go second, and I'm going to hit the trace button because it's my calc menu. And it brings me up to the calculate menu, which has 7 options on it. Value, 0, minimum, maximum, intersect, derivative, and integral, but we'll save those for calculus. Okay? So, one of those words I've mentioned today, haven't I? If we're trying to find where something crosses the x-axis, we're trying to find the 0. So we're going to use option number 2, which is the 0. And I'm going to hit enter. Now, it doesn't give it to me yet. This is not my answer. This is just where my cursor last was. But it's asking me some questions. And it's going to prompt me. So right there at the bottom of the screen, it's saying left bound. So you need to take your cursor and arrow so it is to the left somewhere of where it crosses the x-axis. Am I to the left of where it crosses the x-axis? Yeah, I am somewhere at x values before it crosses the x-axis. You need to hit enter. And when you hit enter, it will pop up kind of like a really light line on mine. I'm not sure, every calculator shows a little bit differently, but it pops something up, yes? Now, it's asking me another question. It's asking me right bound. So now I put a line that's showing, okay, my x-intercept is somewhere beside this. Now I want the right boundary. I want to put a line on the other side that says, okay, my x-intercept is between these 2 spots. So now I'm going to arrow past it to the right, which in this case, I happen to be above, yes? And I'm going to hit enter. So your x-intercept should be between those 2 lines, if you can see those 2 lines. Okay? One last prompt. It's now asking guess. So for guess, I would arrow back to the left to approximately where the x-intercept is. Honestly, the guess doesn't have to be specific. You don't even really have to do this step. You could just hit enter again. So after you've arrowed back or whatever, hit enter. And now what does it say where it was prompting me? It says 0. This is your answer now that it says 0. Notice, I also know it's where it crosses the x-axis because what's my y value? 0. So your y value should be 0 here, and I know I'm done because it says 0. This is telling me this crosses specifically at 1.324718. Okay? Now, probably should write something more than just an answer down on this paper, shouldn't we? Okay? And what I usually try and do is write some clues, because are you guys going to remember that? Not a chance, right? So what we typed into the calculator was y equals x cubed minus x minus 1, right? When we graphed it, we got some equation that did something like that, right? And we're looking for that point right there. Okay? We're looking for that point right there, which turned out to be x equals, I'm going to give 2 decimal places, so 1.32. Now, what I tend to write as steps is we started with going to second There's a second function, the trace button, which is the calc menu, right? So we went to the calc menu. Then after we went to the calc menu, we went to, is it option 2, I think? I don't know. The 0 option, yes? From there, we just followed our prompts, okay? And honestly, the best thing there is to just, it takes some practice. So what is it? 1.324718. Okay? I don't know, write down whatever else you need to know to remember. Or what are we going to have to spend some time on Monday doing also? Reminding you how to do this, right? Okay. If you haven't already written down the homework, make sure you get that done. Your homework is listed as 2 through 34 evens. Now, follow the directions on each section. Do they want you factoring? Do they want you graphing? Do they want you quadratic formula? Do they want you completing the square? Follow the directions, right? What I have written on there, I forget what, I think 2, 4, and 6 say factor and confirm graphically. Just factor is what I'm saying. Okay, that's what these comments are saying, that on 2, 4, and 6, just factor. No graphs. Now, on this one, this is kind of really the best work we can show. There's not really a lot of work to show on this. Okay?